So the theme of our webinar today is to go over some major features that we introduced in Rapise 8.4, as well as a couple of UI improvements that you may benefit from. So let's get into it. So first of all, if you want to find the full list of changes in Rapise 8.4, you can always go to rapisedoc.inflectra.com, and Rapise 8.4 right now is the top item in the list. And here you may find the brief description, and the most important, you will see there the links to documentation sections and to the knowledge base, where you will find more information about every new feature and about every fix that we did. So the agenda for today is we go over a couple of UI improvements that we did in Rapise 8.4. Also, I will introduce you to dynamic test sets that we added in Rapise. And then the major part of this presentation will be talking about orchestration feature in Rapise with the new TestRunner module of Rapise. Last two items, dynamic test sets and TestRunner, imply that you also use a Spira test together with Rapise, because those features are heavily dependent on Spira. So let's begin with description of the new features. So first of all, UI improvement. So here a couple of things probably you waited for a long time that can really make your life easier is a quick filter in object tree and in the files view in Rapise IDE, and ability to reorder our RVL tabs in RVL in Rapise. So I'm going to announce the feature and then do a demo and show you how it works. So let's go to Rapise. So here I have some demo framework opened, and let's go and see how the filters work. Notice that in the object tree and in the files view, you have this edit field at the top. And this is the filter. What it does. So here we have a tree. It has some nodes, it has some leaf items. And if you start typing something here, Rapise will try to find occurrence of the string that you type inside the full path to a node in this tree. So for example, here I have a framework that is used to test library information system. And let's search for the word author. So here we may expand some items, and let's see what was found here. So here we see the test cases that contain author name. Also, let's take a look at this edit book test case. So we don't see author here, but probably we have an object that has author in its name inside this test case. So I'm expanding it, going into objects, expanding the window name, and here we go. So this is the author filter. Also here, as you see in the tooltip, you may use wildcards, and you may use asterisk symbol to search for some more complex things. So if you don't need the filter, then you may click this cross icon, and all items will be displayed. So let's go to files view. Here we have the same thing. For example, if I will search for TestRunner, I will find some items here that contain this word. So this feature really may help you to find what you need quicker than before. So let's look at how you can reorder sheets inside RVL. So let me open some RVL sheet. Here we go. So this is the script, and it has a few different sheets defined. And before, you had to open this as an Excel file in some external editor, reorder, and then reopen this file. So now it's as easy as doing some drag and drop. So here we go. And I just rearranged those sheet names here. So it can make your framework look more polished and easier to understand for other team members. So these are UI improvements. And now we are heading to the first major feature that was added in Rapise 8.4. This is dynamic test sets. So briefly, what it is. So before, you had to manually select every test case to include it into a test set. And if you have thousands of test cases, it could be a problem to find the test cases that you need, select them one by one. So now you can select test cases dynamically using dynamic test sets feature. So, and you may benefit from dynamic test sets not only when you run your test sets using Rapise launcher, but also if you run them locally. So let's see how it works. So again, I'm going to my demo framework and I'm switching to Spira dashboard. So here I see the test sets defined in my testing framework. And let's open, for example, this author management. And here you may see that this test set is dynamic. So how to make a test set a dynamic? So here, by default, you have this filter selected. You can view all test cases in the framework, but you may go to dynamic section and here define the filter expression that will instruct Rapise which test cases to select. So by default, when you first go to this section, the filter is empty, but you may add it. So I'll show it as well. So let's create a new test set as an example. So let's name it dynamic test set. So here we go. And let's switch to dynamic. And when you're just creating a test set and it's not saved to Spira yet, you will see this message here. So you need to put this test set into Spira first. So I'm clicking on Sync with Spira button, and my test set is now created in Spira. So here we go. Now I can switch to dynamic, and my filter expression or selector is empty by default. So how to create a filter? So how to select test cases? You may click here on this checkbox, show filter help, and you will see the reference of the filter expressions. So in filters, you may use the following things. So you may refer to the name of the test case. You may refer to the fully qualified name, which includes the path to the test case. So it will include the folder name as well. So you can use tags, match tags assigned to a test case. Also, you may use test params. So what is test param? Let me check one of the test cases here in the tree. And if we will go here to test params, here we see them. And we can add our own test params if we need to. For example, I think here in create author, I have one defined. So I added an author test params and added my name as a value for it. So if I need to, I may select the test case by using this author test parameter. And also you can, if you're using Spira properties, then you can refer to Spira properties as well. These filter expressions can be pretty complex. So you may use logical operators here, like equals to something, not equals to something, contains, does not contain, and you may also use or and Boolean operators, and you may create sophisticated filters if you need to. So as an example, what filters do I have here? So for example, here I am selecting all the test cases that have author management in their fully qualified name. And basically, these are all test cases inside author management folder. What I can do is I can preview, click here on this preview button and see which test cases are included. So I can see all the test cases here. If this list is very long, then you may filter it and check that the test case that you need is here in this list. So click on OK. What else I have here? So this is the dynamic test set that filters the test cases based on author field. So here I may find all the test cases that I implemented, and if I need to, I may run them and get the result. So here we go. In all other senses, these dynamics test sets do not differ from normal test sets. So you may schedule them, you may run them, you may see the execution status for them. So for example, if we go to test sets, so here we may see the status for all the test sets that were executed in this framework. Okay, but you may run those dynamic test sets not only through Rapise launcher, but you may also quickly select the test cases to run based on dynamic test set filter criteria locally. So if I will click play here on the toolbar, so by default, nothing is selected. Now we have this test set drop down. So I can expand it. And here I see all my test sets. And here I see not only dynamic, but also static test sets as well. So let's select all the author management test cases. So you can see that those test cases were selected. I can click OK, and those 4 test cases will be executed. The last thing to mention about these dynamic test sets is that the syntax of the filter will be familiar for those who ever did some Visual Studio based test case execution. So this thing mimics the syntax of VS Test unit testing framework. Okay. So the next part of this demo is TestRunner public module. And the main idea of this module is to be able to quickly schedule many test sets at once, rerun failed test sets. Also, if something failed, we may now leverage the AI large language models and ask them to analyze the reports and try to find the root cause for us. That may help to quicker find the problem and fix the errors in test cases. Also, with the test runner, you may analyze execution data, so historical data of many weeks or years of execution. So you may find most unstable tests, flaky tests, and get some insights into this data. Also, with the test runner, you may generate reports in PDF format. So if you need it, so you may convert Rapise reports at the end of execution of every test case to PDF and then upload it somewhere or share it somewhere. So I know that many people struggled for this feature. So let's see how it works. First of all, what it means, TestRunner public module. So in Rapise, we have a repository of public page objects that you may use in your testing framework. So let's see where we have them. Okay, let's go to object tree. Here at the bottom, we have this modules pages section. And here I have either framework specific page objects that were created specifically for this framework, like desktop client, login page, new book page. But also here I installed a couple of public modules. So this is TestRunner and this is AI Tester. So how to install them? You may right-click modules and then go to import public module. And here you will see the list of all the modules that are available at the moment. So to use TestRunner, you need to choose TestRunner here. And since TestRunner depends on AI Tester, then you need to install AI Tester as well, because AI Tester is a bridge to large language models that is used to analyze execution reports and provide the results. So once you have these components installed, then you may use them in your testing framework. So the idea of creation of the test runner is that we can quickly analyze the execution results and, if needed, rerun failed test sets. So here is the proposed architecture for the orchestration framework that you may create. So you may have your own framework with all the test cases, with all the test sets that you define, but you may also create an orchestration framework where you will define when and what you want to run, how you want to rerun things if anything failed, and also you may automatically generate summary reports, root cause analysis reports, and get them uploaded to Spira or displayed right on your machine if you need it. So let's see at the diagram how it works. So I'm going to presentation again. So here we go. So the central part here in the execution is usage of Spira run test set action. So we have a global object Spira in Rapise, and it has run test set action. And using it, you may schedule automatically execution of a specific test set on a specific host. So you may define a special test case that will contain a bunch of run test set items, and then you may use this test coverage test case to quickly schedule and run those test sets. And you do this through run tests test case. So this test case, what it does, it triggers execution of all the run test sets from test coverage. Then it generates a summary report. So it may generate a summary report and upload to Spira. Also, if anything failed, it may generate a root cause analysis report. And then it may trigger another test case that will rerun all the failed test cases. So if anything failed, maybe it failed because for some period the system was not accessible or anything like that. So usually when you rerun something that failed, it may pass. So we may rerun our failed test cases. And after we do this, so we will rerun everything failed from this test coverage. We may again trigger a summary report and upload the results into Spira. So this is the diagram, but I also show it in the real framework as well. So let's go back to Rapise. And let's first go to the test coverage test case. So what we have here? Here I have a couple of sheets like management, integration, and on the management, I am scheduling execution of a test set with the name author management that includes all author management test cases, and I'll do the same for book management. On the integration, I trigger a test set that runs all the integration tests. So I may have many sheets here. I may have many test sets built for different purposes. And on the RVL, on the main sheet here in the test coverage, I'm just playing those individual sheets. If we will go to run tests, so this is the main test case that starts the execution. So it triggers execution of everything. So let's go into it. So, and let's go to RVL sheet here. So the central part here is that we are doing RVL do play script, and this is our test coverage. So by running this line, I will schedule the execution of all the test sets that I defined in the test coverage. Then after that, I will schedule the test set that will generate the report. And then I will schedule another test set that will rerun failed tests if needed. So let's see what we have in summary report. So here we go. In summary report, we are using TestRunner, so the module that I am showing you right now. So here we are generating daily summary report for all the test sets mentioned here inside test coverage. So in the test coverage, we are running author management, book management, and integration. And this daily summary report will go through all of them through the recent execution. We'll build the summary and upload this summary to Spira. So this is another action in the test runner. What it does is that the daily summary report will generate the HTML report locally and will return in the last result variable the path to this generated report. And do save file to Spira will upload the result into Spira into the folder with this ID. So what I did is I went to Spira. There I created the folder. Here it has the name Rapise Summary Reports. You may see that its ID is displayed in the left bottom corner as a tooltip. So 165 and so on. And I am using it here. And if we will go to this folder, it contains all the reports that were generated by this framework. First of all, let's go to this one of the recent reports. So this is how it looks like, this test execution report. It lists all the test sets that we executed. Also, it has a breakdown of how many test cases passed, failed, blocked, or were not run for some reason. The most important part here is we have a section devoted to failed test cases. So for example, here, when we executed this, the test case create author failed. Here we may view the input parameters for this test case. We may view the last error message. Also, we may see the last screenshot here. And this is the full execution log of what was executed. So every test set and every test case in it. And if we need to, here we have a link, open test run. And by using it, we should be able to go and view the report. So not sure why we don't see it here. Open test run. Oh, I see. So this the problem here is that we are missing some slash, but so we will fix it, and you will be able to navigate to the test run from here. Also, let's go back here. So besides the daily summary report, we do a test runner, do analyze failures RVL. Again, here we are passing our test coverage test case with the list of all the test sets that we wanted to run. And this thing will go through all of them. We'll find failed test cases. We'll generate for them root cause analysis using LLM, using AI. And then we can upload the result back to Spira. So let's go into Spira and see what was generated. So here I am selecting the attached summary report. I can go to versions and I can open it right away. So here we go. This is our test case that failed, create author. And here we just see what happened and what probably will help us to fix this test case. So sometimes these reports are really useful and provide meaningful insights. So how we generate them? Rapise sends the report, all the steps of what has been executed, and also Rapise sends the screenshots included into the report. And if there are many screenshots, then to save tokens with LLM, Rapise sends just the last couple of screenshots. And here you may see that LLM looks at the screenshot, and also it may generate some insights from the screenshot itself. So let's see how it works if we run this thing locally. So I already executed it. So the problem here is that it usually runs on the recent status of execution of all the test cases. And right now, all my test cases passed. So here I prepared specifically the result of execution of this part. So we may see how the report looks like in Rapise if you trigger this manually. So let me go to test cases, to summary report, and I think this one. Okay, yeah, so I intentionally interfered some long execution of a couple of test cases and made them failed. And then I executed this analysis thing. And here you may see that Rapise found failed test set. Then Rapise found some test runs, downloaded the reports, and then send those reports to AI for analysis. So here we may see AI tester do analyze report. And then a PDF report was generated and here included into Rapise report. So I can click it here and open and see what was wrong. I can go to another one and expand it. Oh, this is the raw answer from AI. And I can open another PDF explaining the problem. And also here I have the summary report. So the report that actually a concatenation of those two, of all other failed test cases. And this is what is uploaded to Spira in our demo. So if you want to use this feature, you need to have your AI configured in Rapise. So to configure AI, you need to go to View, AI Dashboard, and go to Settings. So, and depending on the provider that you want to use, you need to specify the model name, API key, some other things. All right. So let's return back to our diagram. So you saw run tests that executed test coverage. Then it executed summary report, which generated summary report and root cause analysis. And then we are proceeding to rerun, failed, and not run. So let's go back to the framework, to the object tree, and let's open it here. And how it works, this rerun, failed, and not run. It also uses TestRunner do rerun, failed, and not run action. It goes through all the test sets in our test coverage and finds those that failed and schedules execution. And when this thing works, it returns the number of test sets that were scheduled for rerun. And here we have an if statement. So if we had to schedule some test sets to rerun, then let's redo all our summary reports again and upload them to Spira. So if we will return back to Spira, scroll up, we see the report after the rerun, and we see that after rerun, everything passed, and we don't have any failures here. Okay. So here, this is the framework for execution of multiple test sets and rerunning to get the results. So it can be also used to manually run some test sets that you want. So you may always go to test coverage. You may select the test sets that you want to run here and run them. Also, one thing to mention, many of the actions here, they have optional parameters. So for example, here we have run test set with just the name of the test set. But if we will reveal optional parameters here, then you may see more options that you may use. So you may specify the host where you want to run this test set. So by default, it runs on the same host where we run this run test set thing. Also, you may specify the project name. So usually project is identified automatically, but you may also pass it explicitly. And also, last two parameters here is if you want to schedule execution of this test set at specific time, you can do this as well. So let's now go to proceed to analysis of historical data of executions. So I'm going to run test case. And here I have a few more sheets I created. So let's go to this one, do AI report. So what it does. So here with the set parameter, we name the data file where historical data from Spira will be fetched and stored. And then using this file, things like do AI report will build some reports using AI and will produce some PDF reports. So what we have here, we will put our data into TestRun info today file. Then we will analyze history for the project with this ID. So it's actually the project where my framework is saved. It's Spira dashboard test ID 97. I can either specify the ID or I can specify the name here as well. I may choose if I want to include only automated test cases into selection, or I can include everything. Also here, I may specify the number of days to look back to query all the test runs. And then once we do this, we can pass this data to LLM for analysis. And here in the parameter, I have a prompt that I'm sending to LLM of what I'm going to do. So let's see what we have here. Create a report describing test case failures, format a stable, group failures of the same test case, and reduce the number of lines in the table for same errors. So let's actually run this and see what will be generated. So I will play this sheet. And it should get the data from Spira, pass it to LLM, and generate the report. So here we have a report. Let's open it. I think it also automatically is opening when we run it like this. So here we go. So below, we see a report summarizing test case failures. Here we have test cases that were recently executed, actually executed today. You can see here April 30. And different reasons, different error message why something did not work. So if you have a lot of test cases, it may help you to get like a summary that you may store somewhere, share with someone to quickly see and analyze why it all happens and how to resolve all those issues. And here, you may have different prompts. So this is up to you, or what you will write here, what you want to do with this historical data, and how you want to present it. So let's go to the next one. Do AI report Py. So Py stands for Python. And here we may also fetch the historical data of execution from Spira. And then we may ask LLM to generate a Python program that when it will be generated, we will run locally and we'll do some analysis for our historical data. So let me put this somewhere in Notepad so it will be easier to read. So what we do here. So here we will discover which test cases have at least one non-pass status. We'll go again through all the data and capture available runs for those test cases. And then we will ask the Python program to build a plot and show it to us. So let's see how it works. So in order to use this feature, you need Python to be installed, and you need components that you are referring to in your prompt also installed. So if you want to build a plot, then you need to install matplot component in the Python. So let's run it. Play this sheet. So it's now being executed. And now we see that our Python program was generated successfully, since we see the report or like a graph plot that was generated by this Python program. So here we see some test cases, and we see like points where they failed and where they passed. And we have this nice diagram. So you may ask, you may create another prompt, you may play with different prompts and generate other things that you may need. Let's also see the next step here, which is do AI report HTML. So what it can do is it can generate a report in HTML format. And here, so if in do AI report we used analyze run history, we just grabbed the history for certain number of days, and then we did analysis. So the same with is here, but here we grabbed all the executions for the last week. And in the do AI report HTML, we are using TestRunner do analyze flaky test cases. So this thing is selecting a lot of recent test runs. So you may change these numbers here, and it will try to identify the most unstable test cases. So the test cases that has the lower pass rate. And here you may specify how many of such test cases you want to identify and get the data for them. And then once you have this data, then you may want to analyze this data. So you may create a report, or you may build an HTML page with some graph here. So let's run it as well. I'll play this sheet. So takes some time, but it's usually pretty fast. So getting data from Spira is usually very fast. It takes some time to send information to AI for analysis. But not all information in this case is sent to AI. So when we are analyzing individual reports, we are sending everything, but here we don't do that. So what we have here generated. So here we have some summary report. That lists our test cases that failed. We have the error description, how many times it happened. So we may go through this information and see that at some point in the past, we tried to run this TC login script. For the beginning, we couldn't find the button. Then Chrome driver didn't work. Then something didn't work again. So this is pretty interesting information about what was happening. Also, if we will open the browser back, we may see that HTML report was generated. So it's something similar to what was generated by Python. But to generate this thing, we don't need Python at all. And if you want we may attach this report into Spira as well, and it will be visible just like we see this thing. So it will be attached. We will be able to click on it, and we will see this graph attached inside Spira as well. And let's return back to the framework to run tests. And if we will go to examples, so this is not something that we can run from here, but here you may see some ideas of what prompts you may send to LLMs and get the result. So what are top longer test runs? So find groups of test cases that usually fail together. So describe any patterns or regularities you can see in this data. So you may do different things here. The thing that I'm showing you right now, you can try for yourself. So if we will go to the knowledge base, here we go. So how to reach this page? If you are inside release notes of Rapise, then we have a link to TestRunner Module here. If you will click on it, you will end up here on this page. And things that I'm showing you right now are explained here on this long page in a great detail. So everything is explained here. And at the very bottom here, we have a link to the demo framework. So you may just download this framework locally, put it into Spira. So you will need to sync with Spira, and then you are ready to go. So you can run the test sets, you can analyze the data, and so on. The only thing you will likely need to change is the project ID here on those tabs. Will be different in your case. So in my case, it's 97. In your case, it will be something different. So you will need to change it here when you will save this framework into Spira. So this is the TestRunner module. And let's return back to the presentation. And I forgot to show you one more slide here, which summarizes the analysis features of the TestRunner. So you can either do analyze features for RVL, or there is also an option to explicitly pass the IDs or names of the test sets to go through. And it will go through the test sets, will find the failed test cases, will do the root cause analysis, and will generate the reports, individual reports for every test case and the summary report. As for do analyze run history and do analyze flaky test cases, those things are getting data locally from Spira and store them in a local file. And then you may use do AI report actions to do further analysis. So let me show you where those artifacts are located. So let's reveal this framework in Explorer. And here we have AR reports folder. And this is the folder inside the framework itself, where all the data and reports, everything is generated. So it's a temp folder. If you don't need file, you may clean up this folder to save space if needed. But you may always revisit the data that was used to generate something and the generated reports as well. So this is pretty sophisticated stuff, and we'll be happy to sit together with each of you individually. And if you need this functionality in your testing frameworks, then we may organize and implement this together.
Again, I hope all of you watching have gained some valuable takeaways on this release. I hope all of you enjoy the rest of the day, and we will see you next time.
See you next time. Thanks, everyone.